Today we are doing lesson 14.6, titled The Ambiguous Case. We have covered the law of cosines and the law of sines, and they've taken care of, just thinking out loud here, side, 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 angle, side, angle, angle, side. They've taken care of a bunch of these. There's one of these that your geometry teachers told you you couldn't use to prove triangles were congruent, and that's SSA. So we're going to look at SSA today, and it's called the ambiguous case because you really can't be certain that two triangles are congruent if you're given SSA. Now there's some cool things out there on the internet that show us what's going on. One of them, let's see if I can hit this here. At Math Warehouse, if we scroll down this screen a little bit, you could show a video there if you wanted to see their video. And there's this cute little picture here showing the two different triangles. So if we have this triangle ABC and we know this one side BC, look how that side is swinging out and matches with BD. So that's showing that there isn't one triangle that would have that side BC with angle A and angle AB, but there would be two triangles with those measurements. So what happens here is, let me see if I can pick the right pens here and everything. Shape or condition pen. What happens here is, let's say I'm given a triangle with a 30-degree angle here. So there's my angle. And then I should have the two sides following it. So I'm given information on the two sides. Here's the 10. So I'm given a 10. And then I'm given that this other side is 6. So the question is, how many triangles can I build with these measurements? 30 degrees, 10, and 6. And this 6 is across from this 30. So if we take a look and just to see, one triangle that's possible with those sides is here. Right, I'm going to pull that triangle out. So there's one triangle with those sides. 30 degrees, and 6, and 10. And then there's another triangle with the 30, and the 10, and the 6. Okay, and I'm going to pull that triangle out. Whoops, not the whole thing. So we can just grab that. There it is. So this triangle almost doesn't fit. Also has 30 degrees here, 10 here, and 6 over here. So we would never say that these two triangles are congruent, and that's why angle side side is the ambiguous case. We just don't know. So in our notes, we're going to use the law of sines to investigate whether we can have one triangle, two triangles, or possibly no triangles. All right. So it says here, SSA is not sufficient to determine the size and the shape of a triangle in every case. Here's another example. If I had a 30-degree angle, the measure of angle A, and the side across from it was 8, and the side between them was 12. You can see, here we go again, this smaller triangle, or this obtuse triangle, has the same measurements as this scalene triangle, and they are not congruent. So there's two ways to draw that triangle. So the word ambiguous means uncertain, and that's why this is called the ambiguous case. We're uncertain until we do some analysis. So once we do the analysis, we're going to figure out that there could be no possible triangles, one triangle with the measurements, or the two triangles like we keep showing you. So we're going to use the law of sines. there's a lot of analysis in these. So you're going to use the law of sines to do the math. And then we have to think about our answer and look back at our givens. Let's do a couple together. Always draw a picture. So I'm going to draw what I call a partial picture. I'm going to put my angle there on this side and then this side, and I don't completely finish it. So the angle I'm given was 30 degrees. Measure of angle A is 30 degrees. Now make sure you get that side A across from it. And then the other side is the side between them. So using the law of sines, remember I can say side A is to the sine of angle A, as side B is to the sine of angle B. So we're going to set up 5 is to the sine of 30, as 10 is to the sine of B. We don't know what angle B could look like. It could be obtuse, it could be acute, it could be both, it could be a right triangle, or it's possible it won't even exist. Let's do the math and see what we get. 5 times the sine of B equals 10 times the sine of 30. The sine of 30 is a half, so I've got a 5 over here. And 5 times the sine of B equals 5. Let's divide out that 5. And we get the sine of angle B is 1. Do a quick sine inverse and a sine inverse, and you should see angle B is 90 degrees. Well, we knew that. We know that the sine of 90 is 1. So that means this mystery angle is exactly 90 degrees, which means the side isn't going to be out here. It comes straight down and makes a 90-degree angle, and it hits just right here. Think of this as a swinging pendulum. If it swung, it wouldn't hit my edge anywhere else. So in this example, we've got a perfect right triangle, and that means one triangle exists. One triangle with these measurements. Let's try another. Number 2. Partial picture. Angle A is 45 degrees. Side A is across from it. Side B is between. We're wondering what this angle might look like. Law of sines. So 6 is to the sine of 45, as 10 is to the sine of, I'll just call it B. Cross multiply. We're going to divide by 6 and have that the sine of B equals, let's put this in our calculator, 10 times the sine of 45, enter, divided by 6, and just do a quick check, make sure you're in degree mode. I've got that sine of B will equal 1.178511302. The sine being bigger than 1, not possible. Even if you try a sine inverse on these, you won't get very far. You will get an error. So it's not possible. So how many triangles do you think we can draw? Well, it's not possible. There are 0 triangles possible. 0. Let's try another example. Number 3. Draw our partial picture. Notice my angle is obtuse. So let's actually draw that angle obtuse. Angle C, 150 degrees. So side C is across from it. We'll throw that out here and just put a 10. And the side between them, 9. Still looking to see if this triangle over here is possible. Possible, or if there's an answer. Set up your law of sines. 10 is to the sine of 150, as 9 is to the sine of, this time it's actually angle A. You could even put an X there, whatever you want. Cross multiply, 10 times the sine of the angle equals 9 times the sine of 150. We're going to be dividing by 10. I kind of know in advance here that the sine of 150 is the same as the sine of 30. It's in quadrant 2, and that's going to be a half. So these should turn out to be nicer numbers. Let's plug this in. 9 times the sine of 150 divided by 10 is 0.45. All right. So now what we want to do, we're analyzing this now. And we're going to use QRS to help us through our problem. The sine is equal to a positive number. So I know that could be in quadrants 1 or 2, which is opening it up to be positive or negative. Let's do a sine inverse and see what our reference angle is. Sine inverse of 0.45 is a reference angle of, let's say, 26.7 degrees. So that would be the reference angle and the answer in quadrant 1, the acute answer. And the obtuse answer, remember we just subtract from 180. So I have 153.3 degrees. So the analysis comes in, because we've done our QRS before. We've gotten our 2 answers for finding an angle. We've done that a lot. But now we're in an actual triangle. So in an actual triangle, could this angle over here be 26.7 degrees? And I would say, okay, I can add these together, and I'm still under 180, so this one is good. Next question. Could this angle over here be 153.3 degrees? Well, we know that's ridiculous because the triangle's already obtuse. The angles of a triangle add up to 180. That one's way too big. So we actually reject this second answer in quadrant 2. And how many triangles are possible? 1 triangle. 1 triangle is possible. All right, let's do number 4. We have a triangle with D, E, and F. Partial picture. I see it's 15 degrees. It's very small, but I'll draw it like that. That's angle D. Side EF would be side D. And in between 24. So that's E, and there's an F down here somewhere. Okay, let's set up our law of sines. Every time we do ambiguous case, SSA, we're going to use law of sines. So 18 is to the sine of 15. Maybe stop the video and see if you can get to the end of this without my help. 24 is to the sine of F. So pause the video, cross multiply. use my calculator to get my decimal. 24 times the sine of 15, enter, divided by 18. All right, that's hard to read. 0.34, 509200601. So to find angle F, I'm going to do a QRS. It's equal to a positive number. This is a positive number, which means I can consider quadrant 1 and quadrant 2. Let's do a sine inverse of 0.34509 to get our reference angle. Let's say it's 20.2 degrees. We'll go to the tenths again. So now consider the acute answer and the obtuse answer. The acute answer is in quadrant 1. That would be 20.2 degrees. Let's find the obtuse answer. Subtract 20.2 from 180, 159.8. Okay, so we have two possibilities. Go back to the picture. We're trying to figure out, with a 15, can I have 20.2 degrees? And yes, that's a good answer. Now the obtuse possibility, 159.8. So we would add 159.8 to our given 15, and I get 164 degrees. That means the obtuse is another possibility. So there we go. Both angles work with the givens, and so in this case, this is truly the ambiguous case, two triangles are possible. Awesome. Two triangles are possible. So let's see. Let's do the word problem down below. Look, if you set these up, this guy's obtuse, so draw it obtuse. Get it ready. It's angle B. Which side is across from angle B? It would be AC, which is 12 radical 2, and then between them is 12. So that one's all set up if you want to give it a try. And in this last one, angle A is 45, the side across from it is 8, and between is 10. So all set up for you to try it on your own. Let's do the word problem. Max has a triangular garden. He measured two sides of the garden and the angle opposite one of these sides. He said that the two sides measured 5 feet and 8 feet, and that the angle opposite the 8 foot measured 75. Okay, let's get that in a picture. So he's got two sides measuring 5 and 8, and the angle opposite the 8 is 75. So 75 degrees is across from the 8, and the other side is 5. Well, that's angle side side, or side side angle, so we know it's the ambiguous case. Can a garden exist with these measurements? So the first thing they're asking is, can we even make a garden? So to know if this side reaches, we need to figure out this angle. Set it up. Side of 8 is to the sine of 75 degrees. As that 5 is to the sine of, we don't know that angle. Pause here if you want to try it on your own. Get this part done. So 5 times the sine of 75 divided by 8. 6.603703641 don't round these. And second sine, do a sine inverse to get the angle possibilities, just actually the reference angle you'd be getting there, because we're always looking in quadrant 1 and 2 for the acute possibility in quadrant 1 and the obtuse possibility in quadrant 2. So I have as my reference angle, second sine of that decimal, 37 degrees. So the acute answer would be 37 degrees. And what's the obtuse possibility for the math? I have 143. Now analyze. Are they both good? Up here, could this angle be 37 degrees? And yes, indeed, we come out way under 180. Could this angle be 143 degrees? And that's over 280, so we are rejecting the obtuse answer. No good in quadrant 2 here. So we're going to say our angle, and I rounded these to the degrees this time, is 37 degrees. So can a garden exist with these measurements? Yes. Could there be two gardens of different shapes with these measurements? We just determined that. No, it is not the special ambiguous case. And then write the angle measures and the lengths of the sides of the gardens. All right, well, what do we have then? We have a 75-degree angle across from the 8-foot side. We have a 37-degree angle across from the 5-foot side. Let's get rid of this 143. We know now that's 37. And can you find this angle up here? 75 and 37 leaves you with 68 degrees. And the side across from that is? How are we going to find the side across from that? So now you have some choices. Since we've been using the law of sines, let's use the law of sines to go find this side. I will call it n, since I already used x. Okay. 8 is to the sine of 75 as n is to the sine of 68. Quick cross, multiply and divide. Give it a pause if you want to try it yourself. You should try it yourself. Just see if you got the answer right. That side is 8 times the sine of 68, hit enter, divided by the sine of 75, hit enter. I've got that side is 7.679130876, so I'm going to say approximately 7.7.